Again, my name is UNAVCO. I'm from Bowling Green State University in Ohio. Today, I will be sharing some of my ideas that what we can potentially learn from combining GPS and GRACE. So if a technique has a long history that we do not call it old, we call it classical. So the three classical pillars of geodesy are the Earth's shape, Earth's gravity field, and rotation. So in this meeting, we have been talking a lot about GPS as another very important geodetic tool that GRACE. That is GRACE. GRACE is measuring the gravity change and the time variable change of the gravity field of the Earth. So then the next question is how can we correlate with GPS and GRACE? The most obvious way is that if we assume all the gravity change measured by GRACE is due to surface mass change, we can directly modeling its resulting surface loading deformation and compare with GPS. So the comparison so far indicate that for the regions with large scale seasonal hydrological mass change, the GRACE match GPS. And it's also very interesting that even for the horizontal component, agreement is also reasonably good. For the Amazon River Basin, we do see that both GPS and GRACE indicate the crust moving away from the load when the load is decreasing. And I want to potentially point out actually the horizontal loading deformation is very, very helpful. John Wall's previous work has already confirmed that by looking at horizontal loading deformation, we can better estimate the location of the mass change. So in Alaska, the loading deformation and the tectonic deformation are superposed with each other. Using GRACE model the loading deformation, we can remove this component only looking at tectonic transit. So ITRF, the reference frame doesn't include season component. We can potentially incorporate GRACE model, the global loading deformation seasonal component into the reference frame to better improve the reference frame. So right now, more and more people are looking at water storage change inverted from GPS loading deformation, especially for the Western United States where we have a so dense network. So GPS and GRACE are complementary to each other. We know, because of the battery problem of GRACE, there were several months we don't have a GRACE solution. GPS can potentially fill the water storage change for this month. And there are some unique advantages from GPS that, okay, we have confirmed that because for GRACE, the spatial resolution is limited. But with a dense GPS network, we can provide water storage change with much better spatial resolution. Another problem of GRACE is that based on the current GRACE data processing strategy, they have 2 or 3 months of data latency. But we know GPS can be potentially in real time, and we can provide water information in real time. So for tectonics, and we know earthquake with magnitude larger than 8.5. The co-seismic gravity signal is so large that it can be captured by GRACE. And we also know that large earthquake at subduction zone can generate tsunami. For this potentially study, we really want to bring the oceanographer into this party because the seafloor deformation can be better constrained by the tsunami data. And now we have ground deformation measured by GPS and the seafloor deformation constrained by tsunami. And we can potentially improve our modeling of co-seismic rupture. And with this improved co-seismic rupture model, we can forward calculate its resulting gravity change and trying to compare with GRACE. And for this purpose, we know we have to do some tricky things like truncations, like applying Gaussian smoothing, but that's not a big deal. We can do that. If we do everything correctly, so the model of gravity change should be consistent with GRACE measurement. So now we try to combine Tsunami, GPS, and GRACE and to study tectonics. So today I want to convince you guys by combining GPS and GRACE, we can do a lot of fun things. We can do hydrological loading deformation, we can monitor water storage change, we can study the co-seismic process. And if you are a pre-tenured assistant professor, you know what this cartoon is talking about. So I hope our colleagues, when you review our papers and proposals, also think about this cartoon. And let us have a real life. Thank you.